Hello everybody, this is Dr. Norman. In this video presentation, I'm going to talk about strategies for analyzing quantitative data. As we have seen before in our definition of research, research is a systematic process of collecting, analyzing, and interpreting information or data to increase our understanding of a phenomenon about which we are interested or concerned. So this is the stage where we have reached to talk about analyzing the data. We assume that we collected the data. The first step after collecting the data is to use statistics. And what is a statistics? Statistics is a group of computational procedures that enables us to find patterns and meaning in numerical data. Now, in our procedure for dealing with the data, the first step after we collected the data is to store the data into a database. An electronic spreadsheet such as Excel would be a very good idea to arrange this data into an Excel. Some of the advantage of using the electronic spreadsheet would be that we will be able to sort the data, search the database for a desired information, recode the data, graphing also from the data, calculating some formulas from the data, and employing some trial and error scenarios on the data. Now, one more advantage of using the database such as Excel is that the data we store in Excel can be imported into some of the statistical software that I will be introducing for using our computational procedures, such as SPSS, Statistical Package for Social Science. Now, the statistical procedure we use depends on the nature of the data. So, is the data collected for one group or is it for more than one group? And therefore, should we use a univariate procedure or a multivariate procedure? A univariate procedure for dealing with one group. A multivariate procedure will be using for more than one group. Does the data include continuous data for a continuous variable such as age, grades, and so on, or a discrete variable such as a number of accidents, a number of enumerations of counting procedures. Did the data represent nominal or ordinal or interval or ratio scales? And that also dictates the strategies that we use for our statistical procedure. For instance, when we are dealing with nominal data, the only procedure that we can use to summarize this kind of information would be to use one of the measures such as the mode. So that would be the only procedure we use to analyze this, or the percentage of the different groups of the nominal scale. However, for ordinal data, we use other procedures such as the median to analyze the data and compare the data. For an interval or ratio scales, we have many other procedures such as calculating the mean and geometric mean and the median also. Um, do we have the data also that can be described as it is a normally distributed or it is a skewed, it is a non-normal distribution? That will help us also which kind of a procedure should we use numerical procedure such as a what we call it parametric statistics, or we use some other numerical procedures such as non-parametric procedures. Um, in in using the statistics, we have to measure functions for statistics. We can use the statistics to describe the data, so give us some descriptive statistics such as measures of location, measure of diversion, and so on. And also we can make a statistical inference, assuming that the data that we collected represent a sample from a population of interest, and we wanted to estimate the characteristics of the population, what we call it the parameters of the population. Statistical inference has two branches. One is estimation, and the second branch is testing of hypotheses. The characteristic for statistics, as I mentioned, we can estimate the population parameters using the estimation procedures. We can use different statistics for different kinds of data. We can use a single group versus multi-group data. We can use continuous versus discrete variables. The scale of measurement, all of these are factors that we use in our selecting a procedure. The choice between parametric and non-parametric statistics. Parametric statistics are used when the data reflect an interval or a ratio scale. One more condition is that the data fall into a normal distribution. The non-parametric statistics are used when the data are ordinal in nature, and or when the data distribution is non-normal, such as it is skewed to the right or skewed to the left. Then we have a chance in here to talk about some of the measures that we use as a central tendency: the mean, the mode, the median, geometric mean. Some of the measures that we use for the variability or the dispersion or the deviations is the range and the standard deviation and the variance. The choosing an appropriate statistics relate to the central tendency and variability depending on what kind of a distribution that we have. Is it a normal distribution or it is a skewed distribution? For normal distribution, we usually use the mean and the standard deviation. For skewed distribution, we usually use the median and the interquartile range for describing the variability of the data. Then we have also assumed that we have data for two variables, and we can deal with the correlation between those two variables, and we measure the association between the two variables. All of these procedures, such as the measures of central tendency, measure of dispersion, the correlation. Also, we can do some statistical analysis such as the regression analysis, which describes how one variable depends on another variable, and we can figure out what kind of a relationship that relates that dependency of one variable on the other. And the statistical inferences that we talked about it before include estimating parameters such as the mean, and estimating the population mean, estimating the population variance, testing an hypothesis about the population mean, or testing a hypothesis about the population variance. As when we do also testing of hypotheses, we are involved with avoiding or minimizing two types of error. We call it type 1 error and type 2 error. Type 1 error is when we do not when we do reject the null hypothesis, when it in fact that null hypothesis uh, uh, is true. Um, Type 2 error is when you you don't reject the null hypothesis and the null hypothesis is false. Let me get back now to what kind of statistical software that we can use. In this course, I have asked you to go ahead and use a free trial for the statistical software called SPSS. And here are the information that you can go ahead and use it. Download that software, install it in your computer, and I will give you some exercises to practice with using statistical software. Learning statistical packages such as SPSS or SAS, which is called the Statistics Analysis System, or other software that will help you to really do some good job with analyzing the data, and it will help you in the future with an experience of dealing with data. Suppose you have installed the database and the statistical package. Here are some, when you open the statistical package, you're going to see this option in here of running the tutorial. And so what I wanted you to do is go ahead and run that tutorial, and it will help you very much. At the same time, go ahead and read Appendix B in our textbook to get you familiar with some of the aspects of the SPSS. That both of them will help you to do a good job on learning how to do using SPSS. Now, when you open SPSS, you're going to see that you will have a spreadsheet format, and you can import your data into that spreadsheet of the SPSS, and you can do the analysis. I will finish in here, and I assume that hopefully this will highlight some of the options that we have in our chapter 11. Good job, guys, and enjoy the course.